Hello everyone, welcome to Practical GCP. So today I'll talk about how to run DBT Core on Cloud Run jobs. And in my view, this might just be the best service to run DBT Core on because its simplicity and it's how easy it is to test even on your laptop to see exactly how it's going to behave and run on production, and also the flexibility that how you can connect it with the rest of the Google Cloud ecosystem. But before we dive into the details, I want to do a quick recap on what is DBT Cloud versus what is DBT Core, on the key differences and why you might want to use one or the other or both, right? And I will then share some of the ways I talked about before, maybe in the last year, on how you can actually run DBT Core in the Google Cloud ecosystem and why they might not be the best anymore compared to the Cloud Run jobs. As usual, we'll do a code walkthrough and a demo, followed by a summary. Okay, let's talk about DBT Cloud first. The thing in DBT Cloud that attracts the most of my attention and actually really helping a large group of teams that I see to really speed up their development, the everyday development, is the GUI, right? It's the browser-based graphical user interface that offers assist of development, just like an IDE you use on your local machine, but all in the browser. So this has everything from all of your model files, the SQL itself, the version control integration, the lineage that you can see as you develop, and the execution, right? And once you finish all your development, it also has the same environment, again, all browser-based, for you to deploy this to the production environment to run it, right? This would allow you to, let's say, scale to a large group of teams, as long as you're doing it correctly, right? Otherwise, it could become a mess. As long as you do it correctly and, have a federated model to make sure the teams follow best practice, and then it can be extremely powerful to unlock the agility of your development. And I think one of the key things of this is because it's browser-based. And this bypasses a lot of the security issues and hurdles on setting up DBT Core on laptops, right? The second point on this is API integration, right? So you do have, so it's not a closed ecosystem. It does have APIs, right? So if you want to trigger a job, you don't have to run it all based on schedule. I do know many of you do, but you can trigger the DBT runs via an API as well. And then especially on the point number 3 is in the last couple of years, I see a really strong growth on the product and offering that it allows things to be a lot easily managed, such as you have multiple DBT environment. How do you connect the models in between? How do you manage dependencies? How do you have upstream triggering the downstream? So those are some of the things that have been matured quite a lot in the last couple of years. So then you might be asking, why do you even bother with DBT Core itself? So I think, first of all, we all need to understand that DBT Core runs within DBT Cloud, right? It's not a separate thing. DBT Core is the open source component, and DBT Cloud is just see as something that make you work a lot faster, right? And then without needing a lot of skills in terms of DevOps, infrastructure, set things up, it all runs within DBT Cloud. But the difference with DBT Core is you still get a lot of benefits with it. So first of all, you can run it anywhere, especially in your own cloud infrastructure with no lock-in, right? If you choose not to do having any kind of locking in, you can run this DBT Core in your own cloud environment. And this is some of the ways I showed in the past and also today as well, so how you can actually run DBT Core yourself in your own environment. It allows you to have a lot more customization in the ways and exactly how you run it yourself. So this includes so DBT Cloud does not have, a strong sense of deployment, right? So it pulls the code from your Git provider and then it runs, right? So it's actually improving the sense of having better kind of deployment concept. Let's say once you checked out your code, you deployed your code, it has a package. It doesn't quite have that, but it's kind of moving towards that direction. But if you want something that you have full control, the source control, it doesn't matter what happens to your version control, like Git provider, it never affects your jobs. And then a lot more customization than you can provide by running yourself, right? So one key things to consider and also keep in mind is DBT Cloud and DBT Core don't conflict. You can even use both, right? So one of the things I found very effective is to use DBT Cloud to do your, the IDE part, the GUI part, to assist with your development. This is probably a few times more efficient than trying to do and set all these things up locally with DBT Core. But it doesn't stop you from running the code is exactly the same, right? You can run these things in your own ecosystem, in your own cloud environment. And then the powerful thing is kind of the point number 3 on the core part is connects to other jobs upstream or downstream with better integration. Because obviously DBT Cloud runs its own environment, and then you have scheduler bay, you have API to trigger, but it's still not part of your ecosystem. Let's say if you want to integrate your DBT job with Cloud Composer, with other, it can be triggered by other jobs. It's just much easier that you can actually run this all within your infrastructure, your own stack. And then it gives you full flexibility however you want to build it, right? So for example, you can run a Cloud Composer job, you trigger a DBT Core execution. And in this session, we're talking about Cloud Run. Let's say you run it on Cloud Run, and then you have a downstream to do something else, right? All part of the same DAG. You don't have to move things around. You don't have to change the environment, and it's all part of the Cloud Composer ecosystem. You can't really do that with DBT Cloud, right? It's much harder. And I think that's kind of the main benefits. You have more, customization. There's no lock-in, and you also you're able to connect with upstream and downstream much easier, right, compared to DBT Cloud. But they don't conflict, these two. Okay, let's go back to one of the first thing that we talk about Cloud Composer. So this is the first way I think I went back a long time ago and saying, look, you can run this in Cloud Composer with a pod operator. But one of the key issues I found, there's a few key issues. So it's really hard to configure. Even you set it up, you can't easily just say, I'm going to run it, right? How do you run it locally? It's not the easiest to do. You have to do a lot of setup with Airflow locally to run this. And then if you want to integrate with anything else, it doesn't really work because it's part of the Airflow ecosystem. You can only run it in Cloud Composer. Sure, your image is independent, but you have to configure it in a way that it has to run in Cloud Composer. And also, it's not the easiest way to test, right? So if you try to run something like triggering a job to simulate exactly how it runs on production, that's quite tricky, right? Now that's kind of the way I think it's the first one I talked about. The other one is about using Cloud Batch. The main reason I was even looking into this was because of the let's say Cloud Functions and Cloud Run. Even in the past, I think it was made available. It can't run for more than 1 hour, I believe, right? So, and that has totally changed. So Cloud Batch is something in the past when we look at it, you can run as long as you like, right? But because it's creating VMs, but also the downside is you have to create VMs, right? Even it's all based on configuration, but you still have to create the VMs, which means it's very, very slow to provision and start the jobs. And one thing I always felt was you spend a lot of time putting all of this together just to run a DBT Core job. That just doesn't feel like worth the time and effort. So this is why I think using Cloud Run job might be the best one, right? So this is a simple diagram to illustrate what this means, and I already covered some of this point. You have DBT Core within the Cloud Run jobs where you deployed it to. It's just a container. But then you have various sort of options. This is where the flexibility comes in. You can trigger from Cloud Run job. You can trigger from as part of the Composer DAG. You can even trigger from your work laptop to see exactly how it's going to run on production. So all of these things you can easily set up and test. So, and I've actually done a quick summary of all the positive points of using it this way. I can't really see any downside though. Feel free to comment on this to see why you think this is actually not the simplest way to run this. But in my view, It's really easy to set up. It's serverless, right? And it's really easy to test. So you can, on your laptop, you can actually test it with SDK. I'm going to give you some examples as well. This is also, once you test it on your laptop, it's the same code that you can use it to, let's say, run it on Cloud Composer, other Cloud Run jobs. Because it all runs within a container on a Cloud Run job. In this case, it's really easy to set things up with, let's say, especially service account. You don't need anything other than the service account, and then it already knows the context, and you just need to grant it some roles and they run, right? So you can do config override. So this is something I'll show you in the demo as well. It's really powerful because you can do one Cloud Run job deployment, and then you can do the configuration override with the entry point, right? Then you can actually run different things such as DBT run to filter the part of the DAGs on your models. You can do a full refresh, and all of these things you can actually define in the override. It's independent, right? You run this. So one of the biggest issues I mentioned, especially with the Cloud Composer approach using pod operators, is it's kind of locked into part of that Cloud Composer ecosystem. You can't easily do stuff like this, right? You can't easily trigger from the outside. And even you have to do quite a lot of hacks. And these are not exactly how things behave on the production environment either. But that is not a problem with the Cloud Run job. There's two ways you can execute this job. You can do it asynchronously, which is quite suitable. Let's say if you have a Composer job, or you wanted to wait, right? You trigger a Cloud Run job, and it runs your, let's say, daily incremental stuff, right? And it's pretty fast. It takes like 20 seconds, right, per execution. And then you probably wanted to wait rather than just async and you have to fetch back. But if you do a full refresh, you probably don't want to wait for 1 hour because it's resource consumption, especially let's say you have Cloud Composer, you actually occupying your Cloud Composer resources for, let's say, if your job runs for 1 hour and then for the full refresh, then it's going to have to occupy that for 1 hour. So you can see both the sync and async option are valid depending on how long the job runs and what your use cases are. And again, it's very fast start time with Cloud Run jobs. Once your job is created and deployed, then the execution time to trigger it will literally be seconds, right? Compared to all of the other solutions, it just takes forever. This one is really, really easy to deal with, and it's really fast in terms of triggering time. This is something I really like, right? Because the Cloud Run GUI has a way that you can, I mentioned about the config override. You can trigger from the console in the Google Cloud Run job console, either by just executing something. Let's say if you just wanted to run, the job failed, and something, let's say a table was corrupted and it got fixed, you just need to recover. You can actually do it from the UI, right? It runs the same job, so it doesn't really matter. But also, you can actually pass the configuration in the UI as well. So sure, you don't want to always do this from the UI, but if there's a cleanup job and something you want to do just like manually every now and then to run the same code, then the console, triggering from a console could be a very powerful option. Just like how you would do it from Airflow in the UI. This is very similar to that. The last not least, which is the Cloud Run job can now run up to 24 hours. So you can configure this in the configuration when you trigger a Cloud Run job. So this is very powerful because before it was only up to 1 hour, and that's why I was quite hesitating to run this in Cloud Run jobs or as a Cloud Run job. But now, let's say this can actually cover all of the use cases, including full refresh. Right, that is quite key because now you can have your full stack, whether it's incremental or whether it's full load, and to all run in the same stack. Although keep in mind, you probably don't want to run something for 24 hours because just because you can, right? Usually is highlighting this a design issue in there if your job takes 24 hours to run, right? Either you probably want to break things down, only run the certain parts, but you do have the option there now, right? So these are all the points I've been thinking and summarizing. Hopefully, if you have anything to add, please let me know in the comments as well. But I'm quite excited on all of these features that you can run it at your fingertips, and it's really easy to set up. Okay. Without further ado, let's look at the code and demo. Right, first I want to go through the code structure with you guys. Right, so again, as usual, I put in this repository, has all of the details in there, so that you can execute the DBT Core on the on a Cloud Run job. So the structure of this project, here you have, it's all in the README. You have the prerequisites, you have the few lines. I'm using poetry in here that how you can actually run this locally, how you can build it. So this basically builds the container and push it to the artifact registry, just like how we used to do this before. However, when you run the job, and this is it uses the cloud builds to do the submission, this is where it creates the Cloud Run job. So let's have a look at the project structure, right? Let's start with the DBT folder. So this one, it should be very familiar with you. This, if you look at the DBT project, is the same example as always, is a Java shop. And here it points to all of the things, including the seed models, on all of the different models, the target directories is all here. But most importantly, you always have the profiles.yaml that points to BigQuery. The method of authentication, this is really, really key, because if you just leave as method auth, so when it runs in the Google Cloud environment, such as in this case, as the Cloud Run job, all you have to do is to give it a service account and then making sure that service account has the right permissions, right? And then it will automatically infer. So when you run it, it will use whatever is in the context within that container, that cloud environment it runs in Cloud Run jobs. So you don't actually need to configure any service account other than attaching that service account as a parameter when you create the Cloud Run job, right? As usual, you set a project, dataset, and thread, and how many jobs you want to run at the same time, depending on the resource you give it in the Cloud Run environment. Okay, that's very straightforward. So here you have also some the seed models. So these are the CSVs I'm just using from examples. Leave them here because and also making sure you have these when you run the demo, because as long as you have these files there, you can't find them, but it will go back to your BigQuery raw tables, which I'll show you in a second. The models, same as before, you have the staging ones and you have the final ones, you have the schema and blah, 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 right? So let's have a look at the Docker file. So the Docker file has instructions on how you can package this thing, right? So I've used a slightly different setup. I don't know whether this is better or worse, but I think it's simple enough and it does work very well. You have poetry installed in here, you create a user, and you have a working directory. Then you copy all of your stuff, excluding all the things you don't want. You have the Docker ignoring here on some of the things I don't want to include. And then all you basically do is to install the poetry, using poetry to install the dependencies, set a working directory to where DBT, or all of the DBT project code is, then use poetry to run your execution. So keep in mind, so so I'll go through this later, but the key thing that here is the entry point, which is this one. You can easily override. So this is the thing I was referring to, the overriding the entry point, and this becomes very powerful. Although you may have a default one such as just DBT run, but depending on what you need and what problem you have, you can change it to DBT run with full refresh. You can use the DBT debug to see whether things have been set up properly. So all of these can be even done, within the Cloud Run job console. Right. So there are two other files I just want to quickly run through with you. One is this build. This is very, very simple. On using artifacts registry. You have a repository created in the artifacts registry, you give it a name, then you basically package it and you tag it, right, as an image. The other one is the most important one, which is where you actually submit, where you deployed the Cloud Run job. I've used the deploy command here instead of, because before you have to create an update, That's not great because you have to have two separate things depending on whether your job is created or not. So with deploy, you can just have one, right? Give it a name, point it where the image is, give it a region, and most importantly, attach a service account so you don't end up using the default one, which may have a lot of permissions, but if you have removed it, it's kind of a shared one, right? This is a dedicated one for the Cloud Run. For simplicity, I just use the convention of the service account based on the DBT Cloud Run job demo, but you can override this stuff based on your need. Okay, finally, the Cloud Run folder. So what is this, right? So this is the thing I talked about on executing, right? So there's two parts to the Cloud Run jobs. The way it works is you need to create the Cloud Run job first. So that's the deployment. Once the Cloud Run job is deployed, it's basically there listening to whatever you want to do with it, such as triggering a run request, right? You can execute the job. And every time it executes a job, it creates something called an execution, and it has a unique ID. And this is something that's going to show up in the UI as well. I'll show you in a minute. But in here, you can see this is where things started getting very powerful. Imagine you're on your local laptop, right? You have this. I've created two things. So these are the Cloud Run. I would call it more like admin APIs. So you interact with the job, but it's just some Python SDKs, which is very cool. So it took a bit of time for me to figure out what exactly you need to pass in there. So this code, you can just copy and paste and use it because it did take a bit of time to find exactly how to use it. But once you figure it out, there's two ways you can run the job. You run the job synchronously, or you run the job asynchronously, right? So if you look at the two examples I gave in here, one is you can run the job. So in this case, you just run a DBT debug, for example, right? So you might want to do something like before you run the DBT job, on let's say integrated with the Cloud Composer environment, you do a debug first, just to see if everything is set up properly before you actually run the job. And so this one, you can easily trigger this from your laptop as well. Let's say you deploy this to the dev environment. You want to see exactly how this is actually going to run on the Google Cloud environment. This is not something you can easily do with anything else, right? But with Cloud Run, you deploy it and then you trigger it. You can play around with all the options. And this one, if you want to, so this is the use case where I mentioned if you have a longer running job, what you might want to do is to run it asynchronously, right? Again, if you run it on the Cloud Run job or Cloud Composer, you don't actually occupy all of those resources. So what you can do is you submit the job and you have you use the other APIs. So in here, this is the job, it's the request API, right? But you can also use the ones that are getting the job information, listing the jobs you have, and it can become very powerful to manage your orchestration and executions. Right, I just want to show you a link, which is this one. I'll include it in the below the video as well. So these are all of the samples that you can use the Cloud Run SDK, the Python SDK for. So you can see the one I'm using, the one I'm taking is from the run job async and unsync, but unfortunately this one doesn't have, it's too simple. It doesn't tell you how to do the how to do the container override, which is what I've got in there. But I'll include this because you might want to make things more sophisticated with other things such as list or getting the information. And depends on what you're getting from the service, you may decide to abort it or continue. That's up to you, right? But in this code, I've got this section, which is where it's very important that you can use the override, which makes this very, very powerful, as shown here. Okay, right. Now let's have a look at the data source on the BigQuery side. So what I've done is I've loaded the 3 CSVs into the 3 raw tables, matching the model name, because this is where DBT is going to find it, right? So you can see this got it's just the same from the DBT demo. You have the customers, the orders, right? And then the payments. So this job will run well, after execution, it will create a bunch of tables, bunch of views, and then it will execute the model. So that's the source tables. In terms of the execution part, right? Before we do the whole demo, I just want to show you what I've got at the moment. So I've already created, let's see to make sure this is up to date, right? I've got 3 artifact version created, and this is something I've just done an hour ago with the latest deployment. And this is just basically what we had in the version control with Docker file using the cloud build build.yaml, right? That gives us, it does the submission and it gives us one of those versions. And I've actually deleted all of the jobs, so you can see exactly how we're going to do it from scratch. So right now, we're going to run the create. So again, back into this, what's going to happen is we'll run the job and deploy the job. So it should become available after the deployment, right? So let's do this. So I've left all the commands in here. So all you should need to do is go to the command line and do the submission. So now you can see it's deploying and it's really fast. So I think it took about, well, quite a bit of time to actually download the package for the Cloud SDK. But then once it's done that, it took like, what, 5 seconds to deploy the job. If we go to the Cloud Run Job console, now you can see the job has been deployed, right? So in here, you can see all of the informations and the configuration. You can see I've got the task as 1. That was 10 minutes, right? And then the parallelization is not limited at this stage. You have a CPU allocated. Again, because this is the DBT job, it doesn't actually use much resources at all, even if you give it many threads to run at the same time. So you can adjust this accordingly depending on how much resources it takes, but it doesn't actually use a lot. But it depends on the parsing required, but it's, again, the main execution is running on BigQuery in this case, so it doesn't actually use much compute at all. This one thing that is important to see is like here, you've got the service account attached to this. So this is very important because you need to give it at least the the BigQuery editor and then the BigQuery job runner. So you can actually get access to the data set and then to do the execution, right? So let's have a look at this, what's the interesting part. So in the execution, right now, let's just start with the console. I think this is the most powerful part. Let's say you just want to test it out, right? And then see exactly how it runs in the cloud environment with Cloud Run Job. So you have 2 options. One is you're just gonna execute. The other one you can execute it with an override. I'm gonna just trigger the execution. So you see this is coming up, right? It's triggered, it's running, it's in the logs, right? While we're waiting for that, let's have a look at what's inside the execution with overrides. So again, these can all be done in code with the Python SDK as well. There's a few key parts, right? In terms of the number of tasks, I don't really see, at least for now, I can't think of a reason why you would want to have more than 1 task, because this is not something you need a lot of compute to run on Cloud Run jobs. So I'll probably just leave it as 1, right? The timeout, this is the one where I was saying that if you change it to hours, you can actually change all the way to 24 if you want, right? And this is the argument. So this is where you can do the poetry run, what is it called? Let's say DBT debug, right? So you can do poetry run DBT debug, and that's gonna do the debugging. So you see I've changed a few things, and if I do the execution, and you can actually trigger it directly from the console. You can see this was finished. It didn't take much time to run at all, right? So start time 33, 31, so 20 seconds, and it's finished. It's a little bit of startup time, but it's very, very lightweight compared to all the other options I was talking about before. You see here, it did the DBT run, right? And that's where it's created all of the models, look at the data, and then it's finished the execution. If you go to BigQuery, refresh the data set, you can see all of these other assets are created as part of that run. Now, the second run we just submitted is also finished. If I go into there, and look at logs, look, so you can see this now has been overridden to do the DBT debug. So you can see all of these things is done the debug, and it most importantly, it checked the connection with BigQuery. So sometimes you don't have the right connections or the right permissions to do the right things, right? So then you can use debug to check these things, and it will tell you what has actually gone wrong. And this can be extremely useful for debugging, which is uncomparable when, let's say, if you're running this in the two other solutions I showed before. And very importantly, so this is, one thing I realized is I can't really get find a way to change the execution name. So the execution ID. It looks like this is always automatically generated. So far, I cannot find a way to replace this or add a prefix or suffix. Because what would be useful is you say debug somehow in the execution, then it's easier to identify what has happened. But it is in here. So you can see that the command line and args in the configuration in containers. So you do have it, right? So you can find a way to extract this information from the run, and then depending on what is in there, you can generate some sort of dashboard. So when it comes down to debugging and understanding what jobs have been run and where in a very, very large scale, many teams, many organizations, many jobs, you do need some visibility, because otherwise if something runs, you probably don't know what happened in there, right? So, but it is there if you're looking for exactly what happened in the entry point. That's where it's been run. Right. So exactly the same thing, right? Exactly the same thing can be then done in your IDE for local development. So this is the thing I was showing you earlier. With all of this code, right? I'll do the first one, right? I'll comment out this one. Let's do the synchronous submission. All I have to do, right, is now it's submitted. It's waiting for it to complete. If I come here and do a refresh, you can see that now this is executed, triggered, running, right? So that's the synchronous option. So you won't quit. So assume this is running from either locally or from a composer environment. You probably want something like this if the job is short-living, right? Let's say 20 seconds, 30 seconds. So when it's finished, you have the logs in here, and you have the information in here as well. You can see what happened with this job, right? You can see the number of retries it did, the execution details, the containers it uses. So all of that detail will be returned to you as a synchronous execution, right? Again, exactly the same in configuration. You can see is the run debug target dev, right? Right now, let's do the async one. Then you see what is happening in there. So if I do the async submission, it will immediately return, and the job is submitted behind the scenes. So it doesn't give you much information in here, but it does give you a feature that you can utilize, and especially if you need IDs and things like that to actually get it back and then track what is going on with this job, you can do that. So this one, we did a full load. So if you go into it, look at the configuration, we have the full refresh, right? So it's the same thing. Again, this one is asynchronous because it could be a job that runs for hours for a disaster recovery process, or just something that you process on a weekend. All of these things that could happen. You may not want to run this in a synchronous way, but it's up to you. You have the option there. So now that's finished as well. So now we have 4 successful executions, 2 done from the user interface, probably for debugging, having a look at what is going on within the container itself, and then you have 2 triggered from the SDK, right? So there you go. Okay, now let's go back to the slide. Let's do a quick summary on this, right? So in my view, use Cloud Run jobs to run DBT Core is a very versatile serverless option or solution. In comparison to the 2 other solutions I discussed, either using the pod operator or the batch mode, not only they're much harder to set up, but it's not as flexible as this one either, especially given the combination of the console-based debugging option. You can trigger from a Python SDK locally, and all of that stuff, I think running as a a serverless in a container for a Google service is extremely powerful, right? So, and it's super easy to set up. That's the thing, right? This whole thing, obviously I've used Cloud Run Job before, but still, the whole solution took me less than 3 hours to put all of this stuff together for you guys, and then this is actually a very production ready solution for you to just plug into your existing stack. Sure, you need to do a bit of tidy up, change the parameters, substitutions from the Cloud Run, the Cloud builds, right, and to kind of plug into your CI/CD pipeline. But this is something that you can deploy independently and then plug into your existing stack, which makes it extremely powerful as an independent standalone execution that you can trigger from anywhere you like, right? So this I think this is the real power in there, and because it makes testing, especially integration testing, significantly easier compared with other solutions, and it's very fast as well, right? Did you see how quickly it was? Not only from the deployment of the Cloud Run job, also triggering the execution of the Cloud Run jobs is extremely fast, and then and it doesn't cost you anything at all, right? Other than the execution of the jobs themselves, and it's very cheap because there's absolutely zero infrastructure to maintain. You don't have to spin up nodes, and like the Kubernetes solution, you don't have to spin up the VMs. And by the time these things finish, it already probably cost you quite a lot before you even started executing the job. And also the ideas of finally with DBT Core or DBT Cloud, I think I kind of did a recap earlier already. I think these are both valid options. You can run them at the same time. I guess at the end of the day, it's all some degree of lock-in that Google Cloud is lock-in as well. But are you just gonna not lock in at all and then do everything yourself? Yeah, then if you do that, that's gonna really reduce your velocity, right? So I think it's kind of a conscious lock-in, and because the core is always open source, where do you want to run your execution? Some of this stuff, in my view, is really key to increase the productivity of the developers, right? Who are the analytics engineers running the DBT development on a daily basis. So that is where I think nothing can beat DBT Cloud, right? But where it gets into execution, especially when things get complex, and if you want some of these mission critical workloads to run on your own infrastructure for your full control, everything is versioned in your area, controlled very strictly by your CI/CD pipeline with the deployment, rather than just drag from something from Git and then run it, right? So then these are the options can be very powerful to run in DBT Core, and especially if you have relatively complex orchestration workload that relies on some DBT jobs to run first to finish the transformation, and then you can trigger the downstream. It could be much easier to either the upstream or downstream to connect using DBT Core and tools like Airflow in Cloud Composer, or some of this other stuff based on events. That's where I was referring to. If something's happening, you might want to use another Cloud Run job, another Cloud Run service, most likely, because there's some events could have been processed and you want to trigger a downstream to reprocess some data, right? And then so it's updated. So these are all your options. But again, I think the biggest benefit of DBT Cloud, I think, is development, and how fast you can set something up, scale a team of hundreds of people, and all doing it together with a very clear structure and ability to do the things end to end. Where the core, you always have the flexibility and where you want to deploy yourself as part of your cloud ecosystem. Okay, I think that's everything I've got for today. Hopefully you think that's useful, and I'll see you next time.
Go out!